Alright, so here we are. This is part 4. We're on question 41. Chlorine has 7 valence electrons. With which group of elements will chlorine most readily bond? Okay, so to answer that, we got to think about the periodic table. Now, you will have a periodic table. It'll be paper on the EOG. Okay, so you don't need to memorize it. You need to know the patterns. So the first thing you need to remember is that everything left of the stair step is a metal. So we got metals over here. Okay? Everything to the right of the stair step is a non-metal. So we got non-metals over here. All right? And then everything on the stair step, with 1 or 2 exceptions. Okay, so this is a metalloid, 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 and metalloid, I think. Let me see. All right. Yeah, so I think that's it. This might be a metalloid too. Wait. All right. But that one that I left blank, that is aluminum, and that is very definitely a metal. Okay? Now, so remember, these are the metalloids. All right. So we got the metals, metalloids, and nonmetals. So from the left to the right, going across the period, you're usually going to have metals, metalloids, nonmetals. Most nonmetals are gases. Most metals are solids. Okay. These conduct really well. They're malleable, which means they can be bent or flattened. Malleable. And they are ductile, which means you can make wires with them. I spelled that wrong. Okay. Nonmetals are the opposite. They are poor conductors, and they are brittle. Brittle meaning that if you try to bend them, they're going to break. If you try to flatten them, they're going to break. If you try to stretch them into a thin wire, they're going to break. So metals and nonmetals are the opposites of each other in pretty much every way. All right, now back to the question we're on. So chlorine is over here. This is chlorine, and it is in group 17. And the question tells us that everything in group 17 has, or it tells us that chlorine has 7 valence electrons. So if you remember, we said everything in group 1 has 1 valence electron, has 1 electron in the outermost shell. Everything in group 2 has 2 valence electrons. Now groups 3 through 12, okay, these are the transition metals, and we're not going to worry about those, okay, in terms of valence electrons. You'll learn about those in high school chemistry, but they can have more than 1 valence number, and we're not going to worry about that right now. Everything in group 13, 3 valence, 14, 4 valence, 15, 5 valence, 16, 6 valence, 17, 7 valence, 18, 8 valence, except helium. Helium only has 2 electrons, period. It has 2 electrons, therefore it has 2 valence electrons. Okay? Everything else, though, in group 18 has 8 valence electrons. Okay? Now, group 1, I promise, I haven't forgotten the question. Okay, I am reviewing lots of things about the periodic table, but I haven't forgotten the question. Group 1 is the most reactive metals. Okay, group 17 are the most reactive nonmetals. Group 18 are the noble gases. Okay, and they are not reactive at all. I think of them as, you know, in the movies or some movies, you have the snobby, you know, stuck up nobles and like, I don't associate with the peasants. All right, that's how I envision the noble gases. They don't react with anything because they're too busy being noble. All right, now, so first of all, we know the answer is not group 18 because group 18 is not reactive, so that can't be the answer. But that still leaves like 16 other that it could be. But here's the thing. The Octet Rule states that elements want, and I'm anthropomorphizing when I say want. They don't want it. It's the way it works. Elements want 8 valence electrons. Doesn't matter how many electrons they have on the inner shells. What they want is 8 on the outermost shell. Okay? Because if they have 8, then they will be like the noble gases. Right? Just like, you know, people want to grow up and be like LeBron or Kim or whoever, okay? Whoever your idol is. And they're probably a celebrity, right? And so, other than, you know, mom and dad, of course, right? You know, but you probably have a celebrity that you at least somewhat look up to and you would like to be like them, okay? So all the other elements want to be like a noble gas. And if they can have 8 valence electrons, then they'll be like the noble gases. Right? So what we got to figure out is which group will have just the right number of valence electrons that if they bond with chlorine, chlorine will have 8 valence electrons. Okay? So let's go back to the question. All right, chlorine has 7 valence electrons. Which group of elements will chlorine most readily bond with? All right, group 18 has 8 valence electrons. 16 has 6 valence electrons. 2 has 2, and group 1 has 1 valence. So then the question is, which one of these will bond with chlorine to give it a total of 8 valence electrons? All right, so feel free to copy any of this, pause the video, do what you need to do. All right, question 42. Which is the best example of a chemical change? So as soon as you see the words chemical change, I want you to think can't be undone. Okay? And I know you're saying, well, you can't, you know, you can't unbreak an egg, even though breaking the shell is a physical change, not a chemical change. Okay? But that you can put the egg in a plastic bag or something. Apparently I think they're Japanese or maybe Korean, but some students like cracked open eggs into plastic bags, put them in an incubator, and they still developed. Okay? So apparently, you know, the egg is just protection. All right. So chemical changes cannot be undone. Chemical changes must produce a new substance. That is the main definition of a chemical change. It produces a new substance. Okay? So if you melt butter, is it still butter? If you tear paper, is it still paper? If you evaporate water, it goes from being liquid H2O to being a gas. Is it still H2O? Could you condense that water vapor back into liquid H2O? Okay, if you cook an egg, okay, now we still call it an egg, but is it the same? Could you cook an egg, put it in an incubator, in a plastic bag, and get a baby chicken? Which chemical equation best represents the law of conservation of mass? So when you see law of conservation of mass, I want you to think mass of the reactants must equal the mass of the products. All right? Another way of saying that is if I have, A plus B produces AB, okay, that meets the requirements of the law of conservation of mass. I have one A on both sides. I have one B on both sides. Okay? If I have A2 plus B produces AB, that is not balanced. I've got two A's on one side, on the reactant side, and I've got one B on the other side. So the number of atoms don't match up. They're not balanced. The masses don't match up. They're not balanced. So this is what we call balanced. This is what we call unbalanced. All right? So really, what they're asking you when they say which of these best represents the law of conservation of mass, they're asking you which of these is balanced. That's what they're asking you. Okay? So if we look at A, I have one A and I have two A's. So is that balanced? One O and one O. I have two H's, two H's. Two O's, one O. Is that balanced? Here I have four hydrogens. Okay, I'm actually going to zoom in here. All right. So I'm going to start over here. All right, this is a total of four hydrogens because I have a molecule of two hydrogens, and then this coefficient 2, that's a coefficient. That coefficient tells me that I have two molecules. So if I have two molecules and each molecule has two hydrogens, that's a total of four hydrogens. All right, I have two oxygens, four hydrogens, and I have 2 times the invisible 1, okay? So that's 2 hydrogens total. All right, is that balanced? I have 2 hydrogens, 2 oxygens, 4 hydrogens, and 4 oxygens. So is that balanced? Okay. All right, if we look at number 44 here, which is most likely a major concern associated with burning fossil fuels. All right. So burning fossil fuels, we produce carbon dioxide. That's a greenhouse gas. So that contributes to climate change. It contributes to the greenhouse effect. There's general air pollution. There's acid rain. Although the acid rain is mainly associated with coal. Okay. There's also ground level ozone. Now, ozone up in the stratosphere, hopefully you learned last year, ground level or ozone up in the stratosphere is good. It protects us from ultraviolet light, right? That's a good thing. Ground level ozone is ozone that we could actually breathe. So, you're out for a jog, you're jogging down beside the interstate, and all the cars are pumping out exhaust. That exhaust is reacting with the heat and energy from sunlight, and some of it is converting into ozone. And then you breathe it in, and it can damage your lungs, especially over time. And then, it's even worse for people with asthma or a chronic lung condition, or they're really old or they're really young. Okay? So, just, ground level ozone, bad. Stratosphere ozone, good. Burning fossil fuels can pollute the oceans. Well, it can. I don't think that's going to be the best answer, though. Burning fossil fuels can remove harmful chemicals from precipitation. Look, I've been preaching a lot about, not preaching, I've been on the soapbox a lot about how fossil fuels put stuff in the atmosphere. Have I ever said it removes anything? No, it doesn't remove nothing. Okay? Burning fossil fuels can remove carbon dioxide. No. Okay? So let's do this. In terms of studying, let's do this. It adds. Okay? It adds harmful chemicals to precipitation. It adds carbon dioxide. This, by the way, would be how we get acid rain. Okay? Burning fossil fuels can produce smog, which can cause respiratory illness. Ding, 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 ding. So that's the best answer. Okay. So what happens with smog is you have your car. Okay, here's your car. You have a tailpipe, and the exhaust comes out. Now, most of the time, you don't see the exhaust. But what happens is some of these particles stick to water droplets. And then, as they stick to each other in the air, okay, then you start seeing it. And that's smog. And so smog is a combined word. It's a combination of smoke and fog. Okay, so it could come about. Let's say there's a forest fire, and then there's fog the next morning. You're going to get smog. And there's a lot of car exhaust because it's a busy interstate in the city or something. You can get smog. Alright, so I'm at 18 minutes for this video, so I'm going to stop here, and I'll see you in part 5.